little bit more help. So for number 7, we want to find and draw the angle at which light will leave the 45, 45, 90 triangular glass block in water. So we're not going to worry about reflected rays. We're only going to worry about refracted rays. And we're going to have to calculate because we want to do this quantitatively. So we've got N water. So we've got water. Water's all around. And we have this glass block. And so for the first, going from water to glass, I want to know what general direction is the ray going to go, A, B, or C? And the answer is it's going to go B because it's going to go straight through. This, again, my theta 1 is equal to 0 degrees, and the sine of 0 is 0, so that means no bending. So it's going to go straight through. And I want you to now calculate using the index of refraction for water and the index of refraction for glass. I want you to calculate what is the angle with which this is going to come out from the glass. So it's going to come out over here into the water from the glass, and I want you to calculate that angle. So you should stop and calculate. All right, so if you've calculated the angle, I want you to tell me generally, is the ray going to emerge here or here or here? And I should label these X, sorry, there's such a long pause, X, Y, and Z. So what do you think, X, Y, or Z? And the answer is Z because we've got N glass, because that's where I'm coming from the glass and going into the water. So I've got N glass, sine theta glass, and that is equal to N water, sine theta water. And I know from geometry, I did this several times yesterday. If I draw my normal, so that's the first thing I'm going to do is draw my normal. This is theta incident, and because of geometry, that's equal to 45 degrees. So I've got 1.5 times the sine of 45 degrees, and that is equal to 1.33 times the sine of theta w. So I need to isolate theta w, so 1.5 divided by 1.33 times sine of 45 degrees. That is equal to my sine of theta w. And so now I just do the inverse sine of both sides. So I'm going to have sine inverse of 1.5 over 1.33. Sorry, my pen's writing really slow. Sine of 45 degrees. And when I did that, I got 54.7, I think. Let me check my calculator. Yeah, 54.7 degrees. So I'm just going to erase this. So the blue line is my normal, and I'm going to do pink. If it just goes straight through, that's going to be 45 degrees, so that will be 45. And I know I'm just a little bit bigger than that at 54. So this is my 54.7 degrees. So, all right, even if it's not exactly 54.7, it's closer than X or Y were. Okay, in a lab experiment, where light from a laser pointer passes from air into a plastic block, the incident angle is measured to be 25 degrees. The refracted angle is 21. So draw a ray diagram for the lab experiment. So I've got a block. It's the first thing I do. Actually, I'll make my block more massive. I'm gonna do a blue block. First thing I do is I draw a normal. And it doesn't matter whether you come in above the normal or below the normal, but I'm going to, let's see. I need to do 90 plus 21 in order to use this. Oh, incident. So I'm going to do 90. Whoa. 90 plus 25 is going to be 115. I just want to make it a little bit more accurate. Nope. I lied. I want to do 180 minus 15, or 25, ignore me. Okay, 155. So that is going to be, and I don't care if your drawings are like super accurate. Just need to be approximate. So that is my angle of incidence. That is 25 degrees going in this way. And then my refracted angle is 21. So I need to think about how to do 21 in terms of the degrees. Oh, I'm like so not going to worry about that. So I'm going to call this 21. So that's 21 degrees. And so that is my lab experiment. Those are the angles. So I want to find the index of refraction for the block. And this is air. So you're just going to have an air sine theta air is equal to n block sine theta block, and fill it out. Okay, so this one, locate the position of the image from the underwater point. From what point does the light appear to have come? So remember the example when we were doing reflected rays. If I have a ray coming into a mirror and it goes this way, so that is my outgoing ray. My eye thinks it originates from back here. So this is what my eye thinks is the origin. So you're going to do that same idea, only in this drawing. So just for a general, do you think that the eye is going to think it comes from over here, so we'll call this X, or over here, and we'll call that Y? And the answer is it's going to come from X, because remember, my eye thinks that light travels in straight lines, so that's going to be a virtual ray. And that's going to be a virtual ray. And so my eye thinks I probably didn't draw those too well. My eye's going to think the image is like over here. Okay, well that was not too good. I should have done my X and Y in a different space. But anyway, this is where my eye thinks the image is going to be. Okay, so the rest of these, I've done the procedure, and just follow the procedure that I've been showing you.